This is going to be laboratory data, part 5, arterial blood gases. Arterial blood gases are an ABG. First value we're going to look at here is the pH, and it measures the blood's acidity. Normal values for male and female should be 7.35 to 7.45. If you have a high value, if it's over 7.45, then they're going to be alkalotic or be in a state of alkalosis. If they have a low value, less than 7.35, they're going to be in acidosis. So less than 7.35, greater than 7.45. Now, neutral pH is 7.0. That sure doesn't look like a 7, does it? Neutral pH is 7.0. So, and that's the pH of distilled water. We are a little bit alkalotic to begin with, but we cannot survive if you're more than 1 point in either direction. I will assure you, if you are at a pH of 6.35, I will take bets all day long that you are not going to make it. You cannot have that much of an adjustment. Matter of fact, people at 6.9 probably have a high chance of not actually making it. It brings in a lot of physiology. The Bohr effect, capillary washing, acidosis from the cellular environment. The Bohr effect is whenever we load something with oxygen, how the red blood cells offload it is they feel a change in pH or know that there's been a change in pH. If you are systemically acidic, as soon as you get the red blood cell into the blood and load it, it's going to offload, which means that you're still in a cellular hypoxia. It never got offloaded to the cellular environment. PaCO2. Normal measures. This measures the amount of carbon dioxide or the gas pressure in the blood, and it should be 35 to 45 millimeters of mercury of gas pressure in there, CO2. High value on this would be suggestive of respiratory acidosis, and that's because if you have more CO2 available, you have the ability to make more carbonic acid. That thing that I showed you in the last slide set, which was carbonic anhydrase, red blood cell bicarbonate, picks up an extra hydrogen molecule. This is carbonic acid. It gets broken down to water and CO2. The more CO2 that you have in the sample, this is an absolute reversible reaction. So if your body is alkalotic or you have more CO2, the red blood cells, carbonic anhydrase, will be putting these together to make more carbonic acid. So high value would be suggestive of respiratory acidosis or low amounts of ventilation. If you have CO2 building up and you don't have enough oxygen in the area, it will put you into a state of respiratory acidosis. Low values, respiratory alkalosis. This is going to be something like hyperventilation syndrome. Telltale signs of hyperventilation syndrome is flip gases, so very, very low PaCO2. Examples would be in the teens, 17 or so, and then their O2 saturations would be pinged at 100%. So completely flip gases. PaO2 measures the partial pressure of oxygen in the blood. Normal value should be 80 to 100. A high value, over-oxygenation or hyperventilation of the patient. Low values would say hypoxia or hypoventilation. HCO3 negative or bicarbonate measured value in males and females is going to be 24 to 30. A high amount of value here, let's say that was 35. You would have too much bicarbonate or you would have base excess. You could be in metabolic alkalosis, or you could have ingested way too much bicarbonate or been given too much bicarbonate. Low values. Base deficit, you don't have enough. This would be a bicarbonate of, say, 19. Metabolic acidosis. Your body's third-party acids have utilized as much bicarbonate as they can, which should be suggestive of metabolic acidosis. Or an increased serum chloride levels could also lower the value. O2 sats measures hemoglobin oxygen saturation. Normal value should be 95 to 100%. High value has no clinical significance. Low values mean hypoxia or hypoventilation. Hemoglobin measures the blood hemoglobin concentration. Normal value on this should be about 12 to 18 grams per deciliter. High value, dehydration. That means you're concentrated, you've got rid of too much fluid, or you have polycythemia, you've made too many red blood cells. Low value, overhydration, you've thinned out things too much. Anemia, you haven't got enough red blood cells to begin with, or hemorrhage. And this is our range right here, 7.35 to 7.45. So we should be in that range somewhere. If we're off at 7.31, then we're acidic. If we're at 7.47, then we're alkalotic. If we're 1 point in either direction outside of that, we're not going to make it. Respiratory acidosis. Let's put some numbers to these. So let's say that your pH is 7.25. The person has a history of COPD. They have a PaCO2, this should be 35 to 45, of 65. And they have an HCO3 of 36. There's steps in this, and it's very simple to do to read an ABG. Step 1, are they acidic or alkalotic? This person here, since they're 7.25, I don't know what the acidosis is yet, but they have something acidosis. And the next question that we need to ask, does it have anything to do with CO2? The higher amount of CO2, the greater chance that they have of making carbonic acid. This person's CO2, this should be 35 to 45 normally. It's 65. So just by those two numbers, without even looking at the bicarbonate, respiratory acidosis. This person just broke up with their significant other, and they're anxious and breathing really fast. Whenever you get on scene, or whenever you get the first ABG, my apologies, whenever you get the first ABG, the pH is 7.56. The PaCO2 is 17. HCO3, since there's not enough CO2 to make it, is 15. We've really been at this a while. So step 1, are they acidic or alkalotic? And they are alkalotic. Step 2, does it have anything to do with CO2? They don't have enough CO2 to make carbonic acid. They are alkalotic, so this is respiratory alkalosis. Metabolic acidosis. Let's say that your patient has a long history of diabetes type 1, and they run out of their medicine 2 weeks ago, and whenever you get there, you see that there's dead pizza boxes everywhere and tons of beer. You get an ABG on this person from your iStat, and their pH is 6.95. Their PaCO2 is 17, and their HCO3 also is like, let's do 15 on this. Step 1, acidosis or alkalosis. Acidosis, because of the low pH. Step 2, does it have anything to do with CO2? The CO2 is too low to be a respiratory cause. So very simply, from that alone, metabolic acidosis. Metabolic alkalosis. This person has eaten or has taken 4 big, large, gigantic boxes of Tums. And they've drank multiple baking soda and water toddies, if you will. So whenever they get to the emergency room, their pH is 7.55. Their PaCO2 is 20, and their HCO3 is say 35. So step 1, acidic or alkalotic. They are in alkalosis. Step 2, does it have anything to do with PaCO2? There is not enough CO2 there to create carbonic acid, so it's not respiratory. So this would be a metabolic alkalosis. That brings us to the end of laboratory. If you have any questions, feel free to contact me, roy.smith@redlandcc.edu or smithr@emsa.net. Thank you.